Imagine you are just driving down the highway. It's a completely normal Tuesday morning.
Right, just a regular commute.
Yeah, exactly. You have your coffee, you're listening to the radio, and maybe you're stuck in the right lane behind what seems to be like a slow-moving truck.
Oh, I hate when that happens.
We all do. So you glance in your rearview mirror to see if you can change lanes and pass, and you see something cresting the hill behind you that makes absolutely zero sense in this environment.
Okay, color me intrigued. What is it?
It is a massive wall of white and black thermal tiles. It is literally the size of an apartment building.
Oh, wow.
And as it slowly overtakes you, and it's flanked by this small army of police cruisers, bucket trucks, flashing lights, the shape just clicks in your brain. You are being passed by a space shuttle.
That is just wild to think about.
Right. Or maybe it's an Apollo-era capsule just creeping along on the sprawling trailer with dozens and dozens of wheels. You watch this piece of history roll by, completely dwarfing the gas stations and the fast food signs, and you have to wonder, how on earth did that get here?
I mean, it creates this incredible cognitive dissonance, right?
Totally.
We're so conditioned to seeing these vehicles either, strapped to a towering rocket or floating in the absolute void of space.
Or sitting perfectly still under the dramatic lighting of a museum.
Exactly. We almost never think about the sheer physical effort required to physically move them between those radically different environments.
Well, for this deep dive, we are getting a literal blueprint of that connective tissue. Our source material today is a highly detailed, honestly incredibly fascinating document straight from NASA.
It really is.
It's dated March 19th, 2026, and it's a draft request for proposal, or DRFP. The title is the Flown Space Vehicle Multimodal Transportation Contract.
Which is a mouthful. But to strip away the government jargon, this is basically NASA reaching out to the private sector and outlining a very unique, incredibly high-stakes problem. They need to know how the best engineering firms in the world would solve it before they officially, hand over the keys and the funding.
So the mission for our deep dive today is to explore the mind-boggling logistics, the extreme engineering, and really the heavy burden of historical stewardship required to move America's most massive and priceless aerospace artifacts around the country.
Right, because as this 2026 document reveals, you can't just call up a standard heavy freight company, give them a pickup and drop-off address, and hope for the best.
Right, like, hey, can you move my space shuttle by Tuesday?
Yeah, no. The scope outlined here is vast. NASA is setting up a 5-year base period contract starting in the fourth quarter of 2026 with a maximum value of up to $300 million.
$300 million? That's huge.
It is. But they aren't pussed for a single move.
Yeah.
This is an IDIQ contract, indefinite delivery, indefinite quantity.
Okay, let's unpack this.
Yeah.
Because you are essentially asking a contractor to be a world-class, heavily militarized moving company on retainer, right?
Basically, yeah.
Like, you don't know exactly what day you'll need to move or exactly how much hardware you're shipping, but you are paying to ensure their specialized equipment and engineers are always just idling in your driveway, just in case.
That's a great way to look at it.
Yeah.
What's fascinating here is that NASA isn't just asking for a one-off move. They are trying to establish a repeatable enterprise capability.
Enterprise capability.
Yeah. They want a proven system in place so that over the next 5 years, whenever a priceless artifact needs to move, whether that's between test facilities, NASA centers, or to public museums like the Smithsonian or Space Center Houston, they have a master contractor ready to act as the ultimate program manager.
And the scale of what they are asking contractors to move is just staggering. The document categorizes them, ranging from what they call small capsules.
Small being a very relative term here.
Right, relatively small, like an Orion crew module or a Mercury capsule. But then it goes all the way up to large aerospace vehicles.
Yeah.
The document specifically uses the Space Shuttle Orbiter and solid rocket boosters as examples of the size and complexity we're talking about here.
Exactly. You are essentially asking a contractor to move a skyscraper horizontally, entirely intact, across public infrastructure.
It's crazy.
They're commissioning a mobile engineering marvel. And the document explicitly requires a completely integrated approach. We're talking engineering validation, route analysis, custom cradle design.
Wow.
Yeah, infrastructure coordination, operational planning. The contractor can't just focus on the driving part. They have to manage the physics of the entire operation, from the initial feasibility study to the moment it rests on the museum floor.
Which naturally leads to the geographic nightmare of it all. I mean, if the scope is to establish a long-term enterprise for moving assets the size of buildings, how do you physically navigate the geography of the real world without breaking anything?
That's the the $300 million question.
Right, because you might be able to find a straight, flat highway in the desert, but getting a space shuttle from a runway to a museum in a dense urban area requires a lot more than a wide-load banner on a truck.
Oh, absolutely. And the core of that challenge is the multimodal aspect of this contract.
Multimodal.
Right, meaning the contractor can't rely on just one form of transportation.
Right.
Depending on the route, the cargo might first need to be loaded onto a military heavy-lift aircraft, like a C-5 Galaxy or a C-17.
Okay.
Then it might need to be transferred to a barge for a sea lift up a tidal river. From there, it might go on to a specialized rail car. And finally, for the overland heavy haul, they use SPMTs.
SPMTs.
Yeah, self-propelled modular transporters.
Oh, I've seen videos of these SPMTs. They look like giant robotic centipedes.
Yes, that's exactly what they look like.
They're incredibly flat, multi-wheeled platforms where every single wheel seems to pivot independently.
They do, and that independent movement is crucial. But the real magic of an SPMT isn't just the steering, it's the computerized hydraulic suspension.
Oh, interesting.
Yeah, when you're carrying a fragile, multi-ton artifact, the platform must remain perfectly level. So if the front left wheel of the SPMT dips into a pothole or navigates a sloped intersection, the hydraulics instantly compensate.
So it adjusts the pressure so the cargo above it doesn't tilt or twist?
Precisely. The wheels absorb the geographic anomalies of the road so the spacecraft doesn't have to.
Okay, that makes sense. But wait, you can't just take a detour with a space shuttle if a road is closed. How on earth do they plan for the unexpected? You still have to fit the vehicle down the street.
You do. And the NASA document demands a transportability engineering assessment. They are checking bridge capacities, measuring turning radii down to the inch, analyzing overhead clearances.
Down to the inch. Wow.
But they also mention temporary infrastructure modifications. They are literally altering the towns they drive through.
Like what? What are we talking about here?
To a startling degree, actually. The contractor has to plan for removing traffic lights, taking down highway overpass signs, grading temporary dirt access roads.
Just building roads for a day.
Yeah. Laying down temporary massive steel crane pads for the transfer of phases, and even reinforcing local roads that were designed for minivans, not rocket boosters.
That is wild.
They even frequently coordinate with utility companies to physically lift or temporarily cut power lines so the spacecraft can pass underneath.
Okay, but I'm looking at this level of route planning, and it strikes me as incredibly fragile. Like, you can measure a bridge down to the millimeter and map every traffic light, but a sudden thunderstorm turns that dirt access road to mud?
Right.
What happens when the physics of the real world just refuse to cooperate with the planned route?
Well, the darker side of that equation is exactly why NASA requires a massive transportation contingency and recovery plan. Contractors must literally have fallback plans engineered for everything.
Everything.
Everything. Weather delays, bridge failures, equipment breakdowns, permit denials, even public protests.
Oh, wow. Protests. Didn't think of that.
Yeah. But the way they mitigate all this before a wheel ever turns is through digital engineering.
So like a simulation phase, they basically build a digital twin of the entire operation.
Precisely. The contractor must provide an engineering modeling and simulation report. They run the vehicle, the cradle, and the transport equipment through a virtual Earth.
That is so cool.
They simulate the exact vibration environments of the specific roads they'll use. They model the dynamic loads the vehicle will experience during a specific 90-degree turn in a specific town.
Wow.
They even calculate how the cargo restraint systems will perform if the barge hits rough water or high winds on a river. It is a complete mathematical dress rehearsal.
So they mathematically prove the bridge will hold the transport, and they digitally prove the trailer won't shake the artifact to pieces.
Right.
But that brings us to the irony of the cargo itself. It's one thing to prove a road won't collapse, but what about the extreme sensitivity of the machine riding on it? Because spacecraft, they're kind of massive contradictions, right?
They are. I mean, these vehicles are designed to survive the absolute extremes of the universe. They endure the hard vacuum of space, micrometeoroid impacts at thousands of miles an hour, and the fiery 3,000-degree plasma of re-entry into Earth's atmosphere.
But they can't survive a speed bump on Interstate 95.
Exactly.
Yeah.
Once they're back on Earth, unpowered and sitting horizontal, their structural integrity profile completely changes.
Makes sense.
They become incredibly vulnerable to very mundane earthly things, like a bumpy highway can cause structural fatigue. Coastal transports expose them to salt air and moisture, which can corrode internal components.
Oh, sure.
Particulate contamination from road dust is a nightmare. Even prolonged ultraviolet exposure from the sun degrades certain thermal coatings.
Okay, here's where it gets really interesting. The contract explicitly outlines an artifact preservation plan. So the contractor isn't just a driver, right? They're essentially tasked with building a custom suit of armor for an object that is already technically armor, but treating it like a fragile Fabergé egg.
That's a perfect analogy. And the custom cradles they have to engineer are marvels in themselves. The NASA DRFP details that these cradles must respect strictly approved touch points.
Approved touch points. So
Yeah, spacecraft aren't solid blocks of steel. There are mapped out areas, often where they originally attached to a rocket where you're allowed to support their weight, but there are also strict prohibited contact locations.
right, so you can't just throw a giant ratchet strap over a space shuttle's thermal tiles to tie it down. They would shatter.
Exactly. The cradle has to grip the vehicle exactly where it's strong and avoid every inch where it's weak. And crucially, for exceptionally significant items, the government requires the transport to be completely intact.
Meaning?
Meaning no cutting, no structural breakouts, no temporary disassembly, and no permanent alteration of the artifact just to make it fit under a bridge. You have to move it as it is, preserving its exact historical integrity.
If we connect this to the bigger picture, this is really about national stewardship. You are moving a piece of American history, not just surplus government property.
Absolutely.
Yeah.
And that stewardship is taken so seriously that the contract emphasizes a strict chain of custody protocol.
Okay.
There's a required baseline condition assessment before the move begins and a post-transportation inspection at the very end. But they don't just, walk around it with a clipboard looking for dents.
Right, I'd hope not.
They use non-destructive evaluation techniques.
Things like ultrasonic or radiographic inspections. But how does that actually prove the vehicle wasn't damaged on the inside during the move?
When you bounce high-frequency sound waves ultrasonics through the metal or composite structure of the spacecraft, the wave travels consistently until it hits a void,
Oh, okay.
like a microscopic internal fracture caused by a harsh vibration on a highway. That sound wave reflects back differently, and the sensors read that anomaly. Radiographic inspections work similarly, using X-rays to see inside the materials.
That's incredible.
Yeah, the contractor has to use these techniques to scientifically prove that not a single internal fracture or microscopic external scratch was added during transit.
Okay, so let's picture the reality of this. You have a priceless, heavily armored, mathematically simulated, yet incredibly delicate piece of history, weighing hundreds of tons, creeping down a public street on a robotic centipede.
Yes.
People are going to look. I mean, you might be wondering why NASA doesn't just fly these on the back of a 747 like they used to, but once an artifact is retired, those carrier aircraft are often retired too.
Right. Or the destination doesn't have a massive runway.
Exactly. So you're forced onto the streets, and you can't exactly throw a tarp over a space capsule and pretend it's a delivery of lumber. How do you hide something that massive in plain sight?
Well, you don't hide it.
Yeah.
You manage the spectacle.
Manage it.
Yeah. The public interest in these movements is immense. It creates an absolute circus. So the RFP heavily outlines strict requirements for public affairs, media, and stakeholder coordination.
That makes sense.
The contractor has to act as a liaison with local law enforcement, manage the massive traffic impacts of those road closures, and remove streetlights, and actively support government media events along the route.
So what does this all mean for the people on the ground? How does a contractor balance the need for extreme top-secret security with the fact that thousands of people are standing on the sidewalk taking pictures?
This raises an important question because it is a massive contradiction, right?
Yeah, totally.
You have intense top-secret government security. The NASA document specifically calls out the need to protect export-controlled technical data governed by ITAR and EAR regulations.
ITAR being the International Traffic in Arms Regulation.
Exactly. That is the ultimate tightrope walk of this contract.
But wait, why is a 40-year-old museum piece still falling under ITAR? It's retired. The whole world has seen pictures of it. Why is it classified as an arms regulation issue?
Because spacecraft technology is inextricably linked to missile technology.
Oh, of course.
Yeah. Even though the space shuttle or an Apollo capsule is a museum piece, the underlying engineering is still highly sensitive. The specific metallurgy used in the engine bells, the exact chemical adhesives holding the thermal tiles in place, the internal structural geometries that survive re-entry.
All of that could be copied.
Right, that physical hardware could still give a foreign adversary a massive shortcut in developing intercontinental ballistic missile technology.
So they aren't worried about someone taking a picture of the outside. They're worried about an adversary getting close enough to take a high-resolution scan of the thruster nozzles or swiping a piece of material that falls off.
Exactly. Furthermore, the contractor has to manage potential hazardous materials still aboard the craft.
Like what?
These retired vehicles often still contain unexploded pyrotechnics that were originally used for stage separations,
Yikes.
or highly toxic hypogolic fuel residues, or even small radioisotopes.
Okay, so how does a contractor balance the need for extreme operational security and hazardous material safety with the fact that they're driving through the middle of a downtown intersection?
They do it by maintaining a highly secure moving exclusion zone.
A moving exclusion zone.
Right. The contractor is strictly forbidden from releasing operational schedules, detailed route information, or technical imagery without prior government approval. They establish and enforce the logistical invisible shield.
The physical security perimeters, the armed police escorts, the hazardous material protocols.
Yep. While NASA's public affairs team handles the cameras, the media, and the public narrative, the contractor's job is to ensure the operation is perfectly secure, safe, and entirely quiet from a data leak perspective, even while it's the loudest, most photographed thing happening in the state that week.
Wow, it is a masterful, delicate dance.
Truly.
To summarize the sheer scale of what we've unpacked today from this 2026 NASA draft RFP, moving flown space hardware is not a trucking job.
Not even close.
It is a $300 million high-wire act of heavy structural engineering, multimodal logistics, historical preservation, and public spectacle management. They are coordinating military airlifts, navigating river tides on barges, running digital twins to simulate highway vibrations, engineering self-leveling hydraulic platforms, and building custom, non-destructive armor, all while managing a massive public relations event and guarding state secrets from foreign adversaries.
When you lay out the mechanics of it like that, it completely reframes how you look at these machines.
It really does, and that is exactly what I want you, the listener, to take away from this.
Yeah.
The next time you walk into a museum and see a space artifact sitting quietly under the dramatic lighting, looking so peaceful and stationary, I want you to remember this deep dive. Think about the multi-million-dollar, multi-year engineering puzzle it took just to get it through the front doors.
Absolutely.
The ultrasonic scans checking for microscopic fractures, the removed traffic lights in small towns, the creeping SPMTs reacting in milliseconds to keep the cargo perfectly level.
The journey to the museum is, in many ways, just as complex and fraught with peril in terms of terrestrial, earthly logistics as the journey to orbit.
And that leaves us with a final thought to mull over. You've just learned how meticulously NASA prepares to transport these giant, historically priceless monolithic vehicles to museums after their flying days are over.
Right.
But as commercial spaceflight completely takes off, as private companies begin launching their own massive reusable fleets every single week, will this intense, preservation-first, multimodal transportation become a bustling, everyday commercial industry of its own?
That's a great question.
Or, as we look to the future, will commercial spacecraft be intentionally designed like flat pack furniture, meant to be easily taken apart, shipped in standard shipping containers, and reassembled on site, changing the very nature of aerospace logistics forever?
It will be fascinating to see whether the logistics adapt to the massive rockets or the rockets adapt to the standard logistics.
It really will, because otherwise you might find yourself driving down the highway 10 years from now and glancing in your rearview mirror to see a spaceship might just become a normal part of your Tuesday commute.